This is Group 6's Cradle to Cradle project, Tackling Traction, presented by Tanner Owens, Hannah Winter, Rishel Marshall, Khalid Alam, and Jackson Edwards. Our challenge was preventing accidents caused by icy road conditions, especially in areas where infrastructure for dealing with snow is less common. For example, here in Lubbock during our last snowstorm, we had barely 4 inches, which for somebody from Colorado is really not a lot, but nobody could drive, so we had to cancel school for 2 days. The biggest reason for this is Colorado Department of Transportation, for example, has nearly 1,000 vehicles designated for snow removal. That's a lot of infrastructure because it's a consistently occurring problem that they have. However, Lubbock has a total of 5 trucks dedicated to this. People here don't tend to buy cars with snow and ice in mind, and so it's also dangerous to drive even when there's barely any snow. This issue could be tackled efficiently by creating a product that's accessible and also made of renewable materials instead of having to hammer down on all of that infrastructure for dealing with snow. Our inspiration solution came from mountain goat hooves, which mountain goats are fairly common in the area that I'm from. There's a lot of foothills, sort of rocky regions. And to deal with this, mountain goats have an almost suction-like mechanism in their hooves. The way this works is they've got a hard outer hoof that surrounds a soft inner portion, so the hard part is able to grip the landscape, and the soft portion kind of conforms to it, which really eliminates any gap between the hoof and the landscape, so it almost grips it, and it gets any available traction that's there, so mountain goats can move with almost total surety in their steps. Our idea from this would be a new form of tread for tires, a single unit of tread looking like 3 bits of harder rubber surrounding an inner soft rubber. We've got a picture of a prototype that I just drew up. We would have multiple units of this tread on the tire so that it could actually be usable. And these essentially would be able to grab any amount of traction that's in the road, whether that be dirt, asphalt, any sort of jagged edges in the ice. And this would allow the tires to functionally add traction to cars that aren't necessarily built for snowy environments. In order to make this possible, we would be working with old rubber tires. These are difficult to recycle and most landfills won't take them because rubber does tend to decompose, but this does offer us a way to reduce waste. We would also be using a production facility, which would require land and infrastructure and also personnel to operate, and machinery that could mold, carve, melt down, and reshape these tires, as well as adding our new production to it.
Material health, presented by Tanner Owens. First off, what is material health? Well, material health is a certificate in which a product is recognized and avoiding using toxic or harmful chemicals in its production. This is done through a review process in which a product is studied at production and the final product itself. This certification is helpful for consumers and industries to be mindful of the product's effect on the environment and overall health. The material health certification is needed for a cradle-to-cradle certification and is the stepping stone for further qualifications. Secondly, here are some challenges our group will face trying to get a material health certification. Tires are made of rubber and synthetic rubber, which is our main issue with a material health certification. Rubber is made from fossil fuels such as petroleum and natural gas, which appear in the banned materials list in the Cradle to Cradle website. One solution may be using natural rubber from tree sap opposed to synthesized rubber, as it is a more eco-friendly option. To optimize our design, we will have to design around using synthetic rubber, and we will need to find an alternative. Lastly, what would our product's rating be? The overall goal is to at least obtain a bronze rating, meaning the product's generic materials are at least 100% recognizable. It does not contain materials in the banned items list and is at least 75% assessed by weight. At this point, it is uncertain to say that we could obtain a bronze rating. However, if we design our product with the guidelines and restrictions in mind, it is definitely possible. Thank you.
For material reutilization for this project, we would be reusing those old tires. There are currently no cradle-to-cradle rubber or tire options on the market. Old tires are really difficult to reuse, and landfills don't tend to accept them because rubber leaches hazardous materials into the environment as it decomposes. Recycling it as mulch is a really common way that we currently deal with this issue, but it doesn't fix the problem because that rubber is still going to decompose and leach those chemicals into the environment. Melting down and recarving tires is a really solid option that we would be able to use for this project. And Although it doesn't solve the long-term issue of rubber eventually decomposing, it keeps rubber out of the landfills for now while we develop a better solution, including the use of para tree rubber, which is more expensive but derived from para trees in Brazil and is better for the environment because it decomposes more naturally.
Energy used for production. So to even understand how to or what energy sources we would like to use, we have to understand the recyclability of rubber and how it is recyclable. Rubber is a highly has a decently high burning point that can reach up to 400 Celsius, and the rubber in tires can typically reach higher melting points, almost into the thousands for Fahrenheit. So this is a huge problem that requires a huge amount of fossil fuels and natural gas, or however you would incinerate things that would cause a mass problem for climate. So a method I have researched into to recycle tires with a higher efficiency and give more materials for us to use and benefit our specific tire design in general is cryogenic grinding. This process is, in short, a process in which you chop the item in use into tinier pieces and then mix with liquid nitrogen to create a very brittle feeling for the object. Some very brittle rubber that is then crushed into small miniature powder that can be mixed into other raw materials. And a good thing for us is it can be mixed into new rubber. And when mixed into new rubber, it's very beneficial because we in our tire are looking for a hard and a soft rubber. So we can mix with the density more, and we are allowed to create a more thicker rubber or a thinner rubber. So it allows us to really get everything together, and it's very beneficial to the environment, not causing as much electricity or even natural gas in that form. It only requires the liquid nitrogen and the cryomel itself. An alternative form to this, while efficient, is pyrolysis. The drawbacks of this, however, are the materials are seldom pure when recovered, and that the energy required is a huge amount of energy, a constant, almost power plant of just energy that, if under failure, could cause mass catastrophe. That if oxygen leaks into, it could cause an explosion. However, there was a documented example of a closed loop of it where it was a completely sealed off chamber and it reached temperatures up to 12,000 degree or 1200 degrees Fahrenheit and was very efficient, thus requiring a massive amount of energy, though something that is very hard to come by, especially if you don't have the money or buying ability for that. To the right is a video showing the process of cryogenic freezing in a cryomill, the piece of equipment that would be used. So now that we know what you need or how to recycle the rubber, we need to know what energy we can use. Electricity will obviously be powered for the mill, as well as the liquid nitrogen to actually fuel it. Any means of electricity would be very beneficial. However, renewable energy, while it would be most ideal, as seeing as we wanted to benefit the environment more than destroy it, and using fossil fuels and such as that would already add to the carbon footprint that we are leaving behind. So anything as solar, hydroelectric, or even wind power would be nice, but though can be unstable as we've seen in the past. If we do melt the tires, however, mentioned in one of the previous slides, that would require some form of the natural gas or coal we have talked about, because of the high boiling point and just the high point that the rubber needs to actually burn. Cryo grinding, though, however, is why we want to avoid that because it's a cheaper. You only need the machine and then whatever liquid nitrogen supply plus the electricity. So hopefully it would not only save the environment in cost, but also be a cheaper and more affordable option, as you would just need the startup of the mill. That, however, could be a little pricey. We would also need some form of electricity to run some of the small assembly lines if we had an assembly line to put the stuff together. If we could even automate any machines to do anything for us, we need either like some form of battery usage in robots to charge or even just electricity to constantly power it would be needed. And if we had something like that, we definitely need a more sustainable and reliant form of energy.
It takes about 518 gallons of water to produce a single tire. Water is important in the tire manufacturing process because it is used as a coolant for equipment. In addition to water's use to cool machinery, water is necessary in the process of accumulating the raw materials needed to make tires. Cryomilling does not require a significant amount of water for the process to occur. However, during the recycling stage, water is used to clean the newly recycled tires. Additionally, water jets can be used to cut and break apart tires in one of the early stages of tire recycling. Disposal. Old and used tires can be disposed by recycling through cryogenic milling to minimize waste and to be used in further tire production, being taken to a designated tire recycling facility, ground up to be used in artificial turf and playground flooring, repurposed in residential use as swings or planters. Although there are ways to recycle old and used tires, many are dumped and disposed of illegally. A popular but dangerous way that used tires are disposed of is by burning them. Open tire fires are dangerous to human health due to the release of carcinogens as they burn. Additionally, toxic chemicals released from tires as they are lit on fire have the potential to leak into soil and surrounding water sources, causing contamination.
Social Responsibility by Khalid Alam. What are the effects of our snow tires in the local communities? Our snow tires would essentially prepare the community for winter weather. As stated before, people in Lubbock do not buy vehicles with snow or ice in mind. We do not experience that much snowfall yearly. It's usually a couple days or weeks at most of the year where we do experience snow. But when it does come, we are not prepared for it at all. Inspired by the recent winter storm, our group has thought of a way to tackle the issue of traction when it comes to these icy roads and these snowy conditions. The snow tires that we've designed will allow people to have better control of their vehicles under harsh weather conditions, which will lead to less car accidents on the road and safer drivability of our cars. When you want to drive under these conditions, our cars with regular tires are a lot more likely to spin or skid on the roads, which can lead to a lot of accidents. And a lot of people do not feel comfortable driving under such conditions, or do not feel comfortable letting their loved ones drive under such conditions. Our tires would benefit a lot of people and just ease our mind to when it comes to the traction problem with icy roads. These snow tires would benefit people who live in places like Lubbock, where it does not snow as much, because people in locations such as Lubbock do not have effective snow removal systems, and therefore driving during a winter storm is actually more dangerous here than in places like Colorado, where it snows a lot and they have an actual effective snow removal system. One of our group members is actually from Colorado, and they said that Colorado has over 1,000 snow removal vehicles at their disposal, while we've only got 5. Also, another way it affects the community is it creates jobs where the factories are, which helps with the economy. And the effects on the environment are mostly on pollution. Tires are not usually there are many ways to dispose of tires. Almost all of them pollute the environment somehow. A lot of people throw away or dump or dispose of their tires illegally, which is not good for the environment, obviously. Some people actually set fire to their tires when they're done with them, which releases toxic fumes into the environment, which cause a lot of health issues for humans and animals, but also it contaminates the nearby soil and air, and it's just not good for the environment. So by using our method of creating these snow tires, we will be taking a lot of these old tires and recycling them to use within our new design, which will cause less pollution, obviously, as there are less tires being dumped out or burned, and more people will actually be motivated to recycle their used tires instead of just throwing them away or burning them. Thank you.